Hello and welcome to the sixth part of the BMS modding tutorial series. In this part 1 we'll start discussing how aircraft are implemented in Falcon BMS. You can hopefully imagine that this topic is anything but trivial. I neither pretend to know, nor to understand absolutely everything about it, down to the tiniest detail. I guess nobody does. I will nevertheless try to provide you with a general overview and go into the details where possible. Inevitably part 6 will be broken down into multiple subparts. Due to the high complexity of certain topics, these specific topics will be broken out into separate parts, which themselves will consist of multiple subparts. You will definitely notice a variation in the scale, scope and depth of different topics, but I will at least try to get you started with some basic stuff on subjects where I lack a deeper knowledge and understanding due to the lack of experience. If somebody finds errors or can contribute, don't hesitate to get in touch with me. Aircraft implementation in BMS can essentially be broken down into mandatory and optional content and distinguished between database integration and game mode implementation. In this video I will give you a general overview about how aircraft are implemented in BMS, what files are required, where are they located and how they are generally linked to each other. Details will be covered in separate videos.
So, what constitutes an aircraft in Falcon BMS? You have, of course, its external 3D model in the BML format and its corresponding textures in the DDS or Direct Draw Surface image format. You can find these if you start from the Falcon BMS main installation directory under Data. Herein you find these subfolders. They all belong to the stock Korea theater of operations that are shipped with Falcon BMS, and if you have add-on theaters, you need to open the add-on theater folder, and herein the same subfolder structure is being mimicked with the appropriate data files specific to this theater. Refer to part 2 of this BMS modeling tutorial series about add-on theater creation. Let's for the moment stick with the stock Korea theater of operations. From here on you go to tear data and objects, and here you find the models folder. It includes all the 3D models in the BML format with corresponding BML model file and parent dat for BML version 1 models, and also complementary files and the DDS texture files for BML version 2 models. Important is that the subfolder numbers here are the index numbers or identifiers. So if you want to call up a particular 3D model from the database or another file, then you always reference this folder number. Other naming conventions are not allowed. For the textures, for BML version 1 models, you have the Korea OBJ folder. It includes all the DDS image files. Here also the limitation applies. You are restricted to numbers as names for these files. The assignment of the textures itself is done within the model, but as said, it's only applicable for BML version 1 formats. And you also have the Korea OBJ high-res subfolder. So if you have higher resolution versions of particular textures for an object, you can place them here. It's only important that they have exactly the same name, so same numbers, so to speak, as in the Korea OBJ folder within the BMS configurator that you can also directly launch from here, config from the Falcon BMS launcher. You have one option under graphics that's high resolution textures, and if this one is ticked, the game will always use those texture files included in the high-res folder, and if this option is unticked, it will use those included in the Korea OBJ without high-res folder. Of course, if there are no higher resolution versions of textures available, those of the stock Korea OBJ folder will be used instead. Also located here under Objects are the database files in the XML format. You can of course open, browse and edit them with the XML editor or any other suitable program that allows you to view, browse and edit these files. But the common approach is to use the BMS editor because it's more comfortable to use. You can start it from here, from the Falcon BMS launcher, the green icon to the right with the editor label on it. In this case, we have it already opened. So let's take a look at what particular database record entries are required and are of relevance thereby for aircraft. We have on one hand the class table. This is the most important file, so to speak, because every object that is defined within the database needs to be defined through a CT record. The index numbers that you see here to the left are the CT record number, so it's the identity for this particular CT record. At the top we have the class data. Herein you define the type of the object, dependent on the defined type. You have the class data pointer, and the additional database record entries that are editable here or settable here, better said, depend on the type defined. For aircraft, it's here under data the vehicle control data and the aircraft control data that you can directly open here. And under graphics you have in the normal field the model number that corresponds to the 1700, would in this case under models be the model folder here with the same 1700, so that's your link between a 3D model, the database, and other files calling up 3D models. So let's move on to the vehicles tab directly under aircraft. These are the vehicle control data, and here at the bottom you see the aircraft control data. So let's just open the MiG-29 here again. So CT record link is established here, so that's the top entry, and it's important that you need to link always from the CT record which vehicle control data and which aircraft control data are used. This cannot be done the other way around. Nevertheless, you get the backlink displayed and can always return to the CT record. Generally spoken, the vehicle data allow you to define a lot of different parameters that are of relevance for this aircraft and provide directly or indirectly all the links to all database files that exist for this aircraft. We have here basic data. These are basic aircraft data. Most of them are self-explaining. Cosine slots. You have a number of different call signs predefined, and these are broken down into slots, so you have to select the appropriate call sign slot. I guess the normal call sign, I'm not entirely sure, is the default one, but dependent on mission taskings and so on, the air tasking order logic in the tactic engagement campaign mode and so on will appropriately select different call signs from this call sign slot. Hit points is apparently the kind of damage level that the aircraft can sustain. The performance data here on the right side, such as minimum cruise and maximum altitude, as well as maximum speed, fuel rate, are primarily used by the AI. If aircraft are controlled by the AI in the 2D world, so not in the 3D simulated world, then they are used those bounding values, so to speak. Engine noise level Probably, I'm not entirely sure, but I think it drives the actual loudness of the engine sounds. Number of crew members simply defines how many crew members are on board an aircraft. The only difference in BMS is the number of pilots or crew members ejecting from the aircraft if it's shut down. Here at the bottom you have the radar cross section and defined 1.00 would be the reference value. That's for the F-16, so it's not exactly an expression of square feet or square meters, but more a relative value compared to the reference. So on the right side you have a lot of checkboxes that you can tick. Not all of them are actually of relevance for aircraft, as vehicle control data are also used by other vehicle types, so ground vehicles, ships, submarines. And you have this bottom section here. Related vehicles provides links to class table record entries. So the 163, the same as here. The other 4 are only of relevance for aircraft that are being added to the dogfight mode. Their record entries are one-to-one identical, with the only difference being the owner that's different. And these owners here, as you can see, Crimson Shark, Viper, Tiger, reflect the different teams in the dogfight mode. Under units, you have the units linked. These can be found here in this tab. For aircraft, primarily of relevance are flights and squadrons, so you need to create 2 record entries, one under flights, one under squadron, and each of them also has a corresponding class table record entry, so that's also mandatory. At the end of the day, you at least need a minimum of 3 class table record entries, one for the vehicle control data and 2 for the unit control data, one for flight, one for squadron. And the only real difference is between flight and squadron that at the bottom section here you define the permissible size of a flight. So in this case, 2 elements for index 0 and 1. That makes a total of up to 4 MiG-29s are permissible. You can of course reduce this. I don't know what the actual limit in this respect is, but 4 means a flight of MiG-29s will never consist of more than 4 aircraft, but it can of course consist of less than 4 aircraft. For squadrons, you simply have a larger number of aircraft defined here, and that's the default number of aircraft, at least for tactical engagement mode. When you are creating a new squadron for an airbase in the tactical engagement mode mission editor, also known as TE builder, then it will have by default the number of aircraft defined herein for the squadrons type. The rest of the content in both flight and squadron should be the same, or not to say it must be the same. What you notice here already is that there is some overlap redundancy between certain entries, such as hitch ends and strains detection range against different target types. This is also primarily of relevance for AI-controlled aircraft, especially in the 2D world. Same for damage effects. The roll scores that are more important because they define the permissible mission taskings. And the roll score can range from 0 to 100. 0 means the air tasking order logic of the campaign, for example, will not generate any mission of the task if the roll score is 0. And the higher the number is, higher is the probability that such mission types are generated. You can also define the main rule here, max range and fuel weight, fuel rate. Fuel weight, fuel rate should ideally match with those data defined in the vehicle control data record entry. Move speed is more a kind of cruise speed. And also here at the defined altitude the equivalent or calibrated airspeed. These data are used by the air tasking order logic for flight plan generation. And also important, what you can look up here is the unit icon. The unit icons mean the aircraft symbols that are displayed on the 2D planning map in the TE and campaign modes. So the position of an aircraft is appropriately displayed with the respective unit. That's a subject that we will look at a different time. And finally, you have also the squadron stores link to from here. In the squadron stores, you simply define the type of weapon stores and the corresponding quantities that are available to an aircraft squadron. That's especially important in campaign mode. Many people make the error that they try to use Mission Commander to set these. You can use Mission Commander more suitably to replenish or also change these values, but the default is defined here in the squadron stores data. Such squadron stores data are needed, but you don't necessarily need one dedicated record entry for each aircraft type. You can also share these if it makes sense, because you have aircraft types with similar weapons, and in campaign mode only those that are included in the weapon loadout will show up anyway. So that's so much about the unit control data. You have also damage stats. Here, once again, as already shown in the unit control data, hit chance, strains, detection range against different target types, mostly for the 2D AI, and we have the weapons part. Here you can add the gun, and you need to define a corresponding number of slots in line with the number of external store stations or also internal store stations the aircraft has, and then you can link to the specific weapon load data. We'll come to it in a while, and also define whether those slots are visible or not, or whether they use recs or not. But this will be described in another video in greater detail. Okay, the aircraft control data are defining the following things. First, the combat class is essentially a AI behavior profile for aircraft in the 3D simulated world. Aircraft data is actually the aircraft data file or flight model file, as you want to call it. We will cover it in a while. And then you can also define which sensors are available to an aircraft and link to the respective record entries for these sensors. You can check out sensors here. We have IR data for infrared search and track systems, only used by AI controlled aircraft. So on a player flown aircraft it's not available. Radar data, radar warning, receiver data, and visual sighting data. These are also used only for AI controlled aircraft and define detection range and permissible angular offsets from the longitudinal fuselage datum. So defining essentially the angular coverage of AI pilots to visually spot and track targets. So that's everything for the database part. Let's now move on to the aircraft data file. It's located also under data sim and then AC data, and let's stick with the MiG-29. You have the aircraft data file. In the past it were DAT files. Since 4.37 update 4, the so-called TXT, PB or Proto format has been introduced. In the 4.38 you will definitely no longer find those DAT files as such. They are, so to speak, the predecessors. The content is essentially the same, but there are also some differences in the nomenclature used. And these files simply contain the flight model related data for an aircraft, but they also include several definitions for visual data, such as those wing vapor data that display the wing vapors. You have to define them here to match them to the 3D model of the aircraft. Afterburner chain data can be optionally used as afterburner effects if they're not included in the 3D model itself. And you also have a number of additional data that you define here under aux arrow. In the past it was called additional data section, so you can select the type AC here, for example. Typically here's F-16 displayed or F-15 or other aircraft. There's not necessarily a dedicated type AC available for all aircraft, at least not at the moment. The principal purpose of this value is to enable specific hard-coded system functionalities if they are available. If not, most aircraft are simply using the F-16 here. And if you want to check out, simply check out other aircraft proto files to determine, okay, what type AC are them using. You can also define the cockpit name here, and cockpit wings parent refer to part 8.0 of this modding tutorial series. Infrared signature and visual signature data, mean time between failures, and so on. So there's a lot that you can define here. Also engine data and emergency power unit data and so on. This also includes not only specific performance or operating parameters, it also includes animations here, for example, for the engine nozzle. So these areas are of relevance when you introduce a new aircraft to the database with a new 3D model. So animations are not only defined in the 3D model itself, but you can adjust limits at least within this aux arrow data section. And this is also true for all kinds of control surfaces. You can define, for example, deflection angle limits. You can define retraction or extension rates of the air brake and so on, and many other parameters that are also of relevance to the flight model. You can enable, disable several systems, such as an emergency arrestor hook or normal arrestor hook. In this case, we see it's not populated with any data. It means the aircraft has none. Wing folding mechanism, wing flex, animation of wing flex, canopy data, fuel data, and so on. So there's a lot that you can change here. Also, the type of in-flight refueling can be defined here between boom and post-stroke refueling. You have several avionics options. These are essentially for the different F-16 variants and versions, but as most aircraft are using the F-16 systems modeling, you can tailor these options to at least best match the aircraft that you are using. And several other parameters of importance here is the linkage to the hardpoints, and also the linkage to specific sound files. So any cockpit internal but also external sounds are defined here. You have the definition of the sound type, that's so to speak the hard-coded trigger, and the number thereafter is the identity of the specific sound file. Of course, those sound files must exist, and you can also remove this if you want. So specific sounds such as a voice message that don't exist in an aircraft can also be simply removed here, and they won't be triggered in cockpits then if they are missing here. So that's just as a brief overview about the aircraft data file. As explained before, you link this aircraft data file from the database aircraft control data in particular. So let's MiG-29 in this case, that's ACD number 23. We can of course also simply go here. It's also MiG-29, it's the same index number, that's the link. And here, but under aircraft data, you select simply the name. It's the same name as for the file, MiG-29A. The ending is ignored. So in this case, you can uniquely identify or find a specific aircraft data file, and you have to link to it if you want to use it with a particular aircraft. So sounds by default, all aircraft that have no custom sounds defined are using F-16 cockpit sounds, but you can, as said, remove certain sounds or change them. You can also link to sounds of other aircraft if they exist. And in theory, you can also create your own custom sounds. The sounds directory is located here. And you have here the sound table that essentially lists all the sounds with specific parameters and links to where this file is, for example, located. And here you have the index numbers. And these index numbers are those numbers that are displayed hereafter. So if you are looking for a specific sound, you can check out the sound table. And if you want to add new sounds, you have to create new index numbers. But that's not everything. You have also to edit the com or eval file. More information about this can be found in the BMS technical manual, so I suggest you to check that one out if you are interested in creating custom sounds. Sounds typically in the OGG format. In the past, it was also the WAV format supported. Might be that that's still the case, but I'm not sure on that one. Okay, so important with regards to sounds is they are also hard-coded, and that means only those hard-coded trigger conditions trigger a sound. So it's still the logic used by the F-16. Of course, external sounds are a little bit kind of generic, but especially with regards to cockpit sounds, there are trigger conditions that are hard-coded. They are tailored to the F-16 or meanwhile also to the 15. But if you're using F-16 systems modeling, the trigger conditions of the 16 apply, but you can either remove or change or replace those sound files accordingly. So the final aspect under Teradata objects is a BMS regdat. In this file that can be opened and edited with a normal text editor, you can define two things. The first one is you can define recs. So these are specific pylons, recs, launchers, whatever. You define the properties of these. And the next thing is that you can also define the rec groups. Let's simply go down with the rec groups. You define the specific stations and also at which pylons are applicable to the stations in accordance with the definitions. What is important here is the defined group name here is reflected in these hardpoints here. Here in the aircraft data file, you have the hardpoint groups, and then in the sequence of the stations, you need to link to the respective rec groups defined in the BMS regdat, but this will be in further detail explained in a dedicated video. Another important aspect that is essentially optional, the cockpits under Art, CKPT Art. Here you will find different cockpit folders for different aircraft types. For more details, refer to part 8.0 of the BMS tutorial series. If an aircraft has no own custom cockpit, then it's by default using the F-16 cockpit. You can of course use any other cockpit that's available with the aircraft of your choice. So if you have no custom cockpit, but say F-16 cockpit isn't the most suitable one, or I want another cockpit from a different F-16 variant, or the F-15's cockpit, F-18's cockpit, whatever, you would have to do this here with the source files. You have 3D buttons that in 3D CKPT, and you have corresponding cockpit models and textures. But as said, that's covered in part 8.0 of this modding tutorial series, so I won't dive deeper into this. And this is essentially everything what you can do with regard to an aircraft. So you have the aircraft data file with the flight model data and all the links to the sounds and also relevant definitions impacting the external 3D model. You have, of course, the external 3D model and textures, and they have the database record entries, optionally sounds, and 3D cockpits. And the other aspect in this equation is the implementation of aircraft in different game modes. So we won't cover this in the greatest detail at this point. What is important is the art main folder. Here you have a lot of different files, and of relevance here is the text IDS folder, because every new aircraft that you want to add needs a name defined. This name is then being called up by other files, so if you want to reference to a particular aircraft, you can look up its name, for example here, and it has an index number. It's sequential, so if you add a new aircraft, then check out whether there are unused slots available. For example, it ends here with 607 and continues here with 1000, so you have some capacity to create a new aircraft here. Under units, you already need the name and define the full name. That's that one, and this is actually the name that is displayed in the plane selection list in dogfight and tactical engagement mode. So in order to actually add aircraft then to the different modes, for the dogfight mode you have the DGFT folder. Here you have to add the user ID for an aircraft. This is once again using the text ID, and this index number that's specific for the dogfight mode. It also needs to be referred to from other files, and you have to edit some other files under play, but that will be explained in a different video. So that's only for the dogfight mode. For the other game modes, you have the campaign folder, and herein you find on one hand the instant action game mode files. These are those with the ending IA or instant action, and the one FIA is the one where you define the aircraft that you fly, in this case in the fighter sweep submode. And with the MIA you have the definition what aircraft you fly and what weapon loadouts it has in the mud moving submode. So it's not very complicated, but we will come to it in another video. Of course, also of importance is the TE planes list, because here you define whether an aircraft is available in the tactical engagement mode. So if you want to create a new mission using the TE builder, you have to add the aircraft here. And that's also a subject that a dedicated video will be devoted to. And finally, you have the save campaign files. So those cam files here are the campaign scenarios. These can be opened and edited with a mission with a mission commander. So if you want to add a new aircraft to a particular campaign scenario, you need to work with these files using mission commander. Finally, you can of course also have the tactical reference. That's this XML file. What's important about TACREF data is under art. You have also the different images for the various objects, and these must be placed in this folder even for add-on theaters. As far as I know, but the corresponding TACREF DB XML file is located under Teradata. So if you are using a custom TACREF database for your add-on theater, you must place this file here and edit it here using an XML editor. I'm not sure whether tools exist that can do this for you, at least none that are compatible with the current format. But the corresponding art needs to go into the art TACREF folder under data. So that's essentially for the Korea theater of operations, but you can of course link to the respective image nevertheless also from your add-on theater. Also located under art are a lot of resource files. These are these RSC files, and here you have, for example, the aircraft icons that are included in these files. And you have similar files for other different icons that are being used. But that's also a subject matter for a separate video. Just to let you know, if you want to add custom icons for a new aircraft that show up in the 2D user interface, this has to be done with certain files herein under art resource, but you will find also certain of these RSC IDX files in certain other subfolders. What is important to note in this respect is that you also have the _FHD folder, which duplicates quite a lot of those RC files, but also the IRC files. And if you want to use them in a custom add-on theater, you have to edit them here. And if I'm not entirely mistaken, you also have to edit them here as well. So you have to duplicate this work. In some cases you may simply copy-paste the file itself, but in other cases it may not work, as there's nevertheless some different content. But this will be covered in a separate video. So that's all about how aircraft are implemented in general, and in subsequent videos I will dive deeper into the details on specific topics. I hope that was already helpful for you to get a general overview, and stay tuned for subsequent video where we'll dive into greater details on the different subject matters. Bye.